Hi guys, we're going to do the check your understanding on page 496. Okay, in each of the following settings, check whether the conditions for calculating a confidence interval for the population proportion P are met. Okay, so let's review. Our conditions now are random, okay, the sample had to have come from an SRS or a well-designed experiment. Independence, which is our 10% rule, which means the population should be greater than or equal to 10 times the sample size, and normal. And in this case, we'll have to do our large counts again. Now, we don't have a P, okay? We don't have a P, we have a sample, okay? Because we don't know what P is. That's what we're trying to estimate. So now we're going to take our sample size times our sample proportion and see if that's greater than or equal to 10. And then, of course, our sample times 1 minus P hat and see if that's greater than or equal to 10. If that large count is satisfied, then our normal condition is satisfied, okay? So for the first scenario, an AP Stats class at a large high school conducts a survey. They ask the first 100 students to arrive at school one morning whether or not they slept at least 8 hours the night before. Only 17 students said yes. Okay, so first, let's figure out what our sample size is. They asked 100 students, okay? And 17 of that 100 said yes. So our N is 100 and our P hat or our sample proportion is 0.17. Okay, so let's go through our conditions. Random, it's not an SRS. It says here that they asked the first 100 students to arrive at school. That is totally a convenient sample, okay? So it's not an SRS, so that condition is not met. Let's check the other ones. Independence, is our population greater than 10 times our sample size? So my sample size is 100. Multiply that by 10. I'm pretty sure there's more than 1,000 students at this large high school. Okay, there's more than 1,000 students at our large high school, so I think that's safe to assume. Okay, so that condition's good. Large counts. Now we're going to have to do our N, which is our 100, times our P hat, which is 0.17. So obviously, N times P is 17. That's okay. And then 100 times 1 minus P hat, what's that, 83? 83 is greater than or equal to 10. So that condition was also met. So the one that isn't met here is random, but the other two are, okay? And we'll talk about what to do when a condition's not met, okay, in a confidence interval. Okay. For the second scenario, it says a quality control inspector takes a random sample of 25 bags of potato chips from the thousands of bags filled in an hour. Of the bags selected, 3 had too much salt. So there's our sample size, there's our N, and our P hat is the 3 out of 25. Okay, so our N is 25, and our P hat is the 3 out of 25, which ends up being 0.12. Okay, so let's go through our conditions. Random, yes, it was stated that an SRS of potato chips was taken. It was an SRS of 25 bags of chips was taken. So that's good. Independence, is our population greater than 10 times our sample? So our sample size was 25, multiply that by 10. I'm pretty sure there's more than 250 bags of potato chips because it said 250 of the thousands, okay? So that's good. Bags of chips. Okay, since it said there were thousands of bags of chips. And then the last one, so that one's met. And the last one is our large counts. Now we'll take our N, which is 25, times our P hat. So obviously that's going to be 3, okay? That's not met. That's not at least 10. We'll do the other one. Let's see, 1 minus 0.12. So that should be, what, 22? Okay. So that's not met, okay? So our normal condition was not met in this scenario, but the random and the independent were, okay? And again, we'll talk later about what to do if a condition is not met. Okay, that's it for that one. See you next time.